You should have your warm-up done, ready to check. So our directions say to find the zeros. So in the first one, it's already in factored form for us. So all we have to do is set each factor equal to 0. So that means we have x equals 0. We have x plus 5 equals 0. And x minus 1 equals 0. So now we solve each of them for x. The very first one is already solved for x, so we move to the second one. Since it's x plus 5, that means we have to subtract 5. So x equals negative 5. Since it's minus 1, we have to add 1. So x equals a positive 1. So there are your three answers for number 1. Moving over to number 2, this one is not set up for us in factored form, so we have to first factor it. Again, one of the first things to look for is your GCF. They each have an x, which means that's what we're going to be taking out. When I take that x out, we're left with x squared minus 6x and then plus 8. Well, it's a quadratic at this point inside the parentheses, so we're going to use our Santa hat method to factor it, or headphones. Or this one is the shortcut one, since our a value is 1 here, so we don't need to group it unless you prefer that. So we're going to go 1 times 8, which is 8, and we need factors of 8 that add up to the middle, which is negative 6. In order to multiply to a positive but add to a negative, that means we're going to need to have two negative numbers, and the two negative factors of 8 that would add up to negative 6 should be negative 4 and negative 2. We can put that directly into parentheses since this is the shortcut one, so we bring down the x from the outside, my two parentheses, x minus 4 and x minus 2. So now it's factored. So now we are finding the zeros, so we set each factor equal to 0. So we set out x equals 0, x minus 4 equals 0, and x minus 2 equals 0. Well, the first one is again already solved for because x is equal to 0. The second one we would add 4. So x equals 4. Add 2. So x equals 2 for the third one. So there are your three zeros, 0, 4, and 2. Here's your homework for last night. Again, you only had to do the evens, so you can ignore the odds that are done unless you did extra practice. The first two, the first one had 4 terms, so you could group it into 2 parentheses and do the greatest common factor out of each parenthesis. When you end up with something like x squared minus 1 or x squared minus 81, that's what we call the difference of squares. One thing you could do is say the b value is 0. So what factors of negative 1 would add up to 0? Well, that would be a 1 and a negative 1. Same thing with the negative 81. It'd be a positive 9 and a negative 9. Or you could simply think of it as x squared means x and x. To get to a negative 81, it's a perfect number, so we're going to have a positive 9 and a negative 9. Same thing up here. X squared is x and x. To get to a minus 1, that's another perfect number, so positive 1 and negative 1. Number 6 and 8. Don't worry about the graphing yet. We're going to work on that today. So you were just finding the zeros. If you did graph, just check with what we're doing today to see if you graphed them correctly. And again, pause whenever needed as I'm scrolling up here. Numbers 10, 12, and 14. This is what we had the last examples of. On number 10, they actually had started the problem for you. So you just had to double distribute twice. And again, you could either multiply the first 2 parentheses or the second 2. It doesn't matter whichever one you're more comfortable with. But for the first one, your answer should be this. Number 12, it should ended up being this. and on 14 we ended up with this. When you have a 0 in number 12, you could either put x plus 0 or just put x, because adding a 0 or subtracting a 0 wouldn't make a difference. Today we're going to be working on our finding zeros, but then talk about multiplicity. And multiplicity is how many times is that 0 a solution when you factor it. So how many times do you have the same number? So our first example, we have x plus 2, x minus 1, and x minus 3, and x minus 3. Now one thing to keep in mind, there's another way to write x minus 3 times x minus 3. So think about that for a second. How do you think you could write that? And hopefully you figured out that it could be written as x minus 3, and since there's 2 of them, as squared. So keep in mind if they have it written out for you, or if they have it with the 2, it does mean the same thing. Well, the first thing we're going to do is find the zeros, just like we've been doing. So if I have x plus 2 equals 0, x minus 1 equals 0. Now here, if I have x minus 3 equals 0, I only need to solve that once, because obviously I'm going to know what the other parenthesis would be then. So the first one is x equals negative 2. The next one, x equals 1. And the last one, x is equal to 3. So we start off that way. So our first answer is x equals negative 2. Well, I only had one parenthesis that would have given me negative 2, so we had say it has a multiplicity of 1, because it appears one time. The next answer is x equals 1. There's only one parenthesis again that could have given me that answer, so it has a multiplicity of 1 again. And then the last one is x equals 3, but this time, whether or not you realize that there were 2 parentheses, or because it did have, we could have written it with a square, which again means 2. So this one appears 2 times, so it has a multiplicity of 2. So go ahead and try the next problem, and then unpause this after you've checked with a partner and are ready to check your overall answers. Here we go, ready to check. Well, the first one, we know we are going to have the 0, x plus 5 equals 0. And then we have x minus 2 equals 0. Now again, it showed up again, but we only need to write it the one time, unless it makes you feel better to write it twice. And then we have x plus 7 equals 0. Well, the first one, if it's x plus 5, that means x equals negative 5. X minus 2 means x equals 2 minus 7, x equals negative 7. So there are my 3 zeros. So I'm going to fill them in here. X equals 2, and x equals negative 7. Well, negative 5, that would appear 2 times because of that squared. So that means it has a multiplicity of 2. X minus 2, the parenthesis was written 2 times, so that means it has a multiplicity of 2. Only one of those parentheses would have given you a negative 7, so it has a multiplicity of 1. So here are your 3 zeros along with their multiplicities. Here is the second you try. Now this one, before you can find the zeros, you have to factor it. Well, we've been practicing that for a while. So I want you to still go ahead and try this on your own. Then check with a neighbor, get help with a partner if you need it. and then unpause this to check to see how you did. So the first thing to check for with factoring here is that GCF. Again, they each have an x, so we're going to take that out first. Which leaves us with x squared plus 8x plus 16. So now the quadratic, what's inside the parenthesis, we're going to use our Santa hat method to factor. So we've got 1 times 16, so that's 16. And we're looking for factors of 16 that add up to 8. So hopefully you found them to be 4 and 4. Since our a value is 1, that does mean that we can put these directly into a parenthesis. So we have the x on the outside, parenthesis of x plus 4, and another parenthesis of x plus 4. Now remember, when you have two parentheses side by side that's the same like this, we could rewrite it to be x times x plus 4 squared. It's fine if you didn't do that. That's just a reminder that that is how it can also be written. So we've got the first x that I'm going to set equal to 0, so x equals 0. And then I have x plus 4 equals 0. Well, the first answer is already solved for. Next one, to have x plus 4, that means we would subtract 4. So x equals negative 4. So the zeros would be x equals 0. It's only 1, so it's a multiplicity of 1. X equals negative 4. That one appears twice, whether it's two parentheses or you write it with the squared. So a multiplicity of 2. Now what we're going to look at is how this tells us what the graph looks like. So multiplicity tells us what the function is going to do at the point on the x-axis, because remember, as we talked about earlier this year, whenever we find a 0, we're talking about the point where it crosses the x-axis. If it's an even multiplicity, which means it appears twice or 4 times or 6 times, anything that's an even number, then it's going to do what we call a bounce. Which will look like a parabola. And think about it, parabolas come from a degree of 2, which is also an even number. So that should make sense. However, if it has an odd multiplicity, so numbers like 1, 3, 5, 7, any odd number, the graph will go through the point and it'll look like a line because it's going to go straight through it. Now the rest of the graph is going to be a sketch, so our sketches will look a little bit different. So if you look at the graph below, let's pinpoint some information here. Notice here how we've got a curve. That means that this had an even multiplicity, so maybe degree of 2 or degree of 4. Here it goes straight through it, so that means an odd multiplicity. And here's the other point on the x-axis, and it also goes straight through it. Now this little curve here, or this curve here, that just tells us the form of the function. And again, when we sketch it, you might draw your curve a little bit lower, or a little bit higher here. That's okay. The main concern is here, the 3 points where it crosses the x-axis. So now we're going to look at graphing cubic functions, and these are going to be mainly sketches, so they're not going to be exact. We just want an overall image. Well, the first thing we're going to do is to find our factors. And factor them. So that could be looking for the GCF, using our Santa hat, grouping, all those different things. We're then going to determine the zeros, which is what we've been doing, and the multiplicity, which is what we were doing just a second ago. And then the third step is, again, to sketch the graph. So we're going to do 2 problems here. So our first example, x cubed plus 4x squared plus 4x, well, the first thing we're going to do is factor. They each have an x, so we're going to take that x out. And now with the quadratic that's left, we're going to use our Santa hat method. So we've got 1 times 4, which is 4. And we need factors of 4 that also add up to 4 here. Well, the only factors of 4 are either 1 and 4 or 2 and 2. So the winning pair would be 2 and 2. Since this has an a value of 1, this is the shortcut factoring where we can go ahead and directly put it in parentheses. So we bring down the outside GCF, and we have parentheses of x plus 2 times x plus 2. Or again, remember, you could have written that as x plus 2 squared. Well, now we set each of them equal to 0. So we've got x equals 0 and x plus 2 equals 0. Well, the first one's already solved for, but we're also going to state the multiplicity, which this is a multiplicity of 1. X plus 2, subtract our 2, so x equals negative 2. This one appears twice, once, twice, so we say it has a multiplicity of 2. Now, going back to the beginning, we talked about even and odd functions and what side went up and what side went down. So we're also bringing that back into play. Well, the first thing is our highest degree is 3. So that means the right and the left side are going to do the opposite. So since the highest degree is positive, that means the right side is going to be up. And the opposite occurs for the other side, so the left side will be down. So that's going to help us sketch our graph. And again, that was back at the beginning of chapter 3. Well, the next thing we know is that at 0, the graph goes straight through it because it has a multiplicity of 1. And at negative 2, it has to bounce because it has a multiplicity of 2, so it has to have a curve shape. So I'm going to put dots at 0 and at negative 2. And now we start with our curves. Well, I know that my graph is down on the left, so here's down on the left, and I know here it curves because that's where the multiplicity of 2 is. Now here's where there's some freedom. You know, when you make this curve, you could make it really low, but know that it does have to come up in order to go through 0. Or maybe you don't want to make it that low and you just want to do a small curve. That part doesn't matter. What you do know is that it bounces here, and then it has to also turn around to get back to that 0. 0 is multiplicity of 1, so it goes straight through there, and there's your cubic function graphed. Looking over at the next one, you've got yourself a U-try. So go ahead, try this problem. Make sure you're sketching your graph in pencil just in case. Feel free to check with a neighbor once you've got your sketch to see if you agree, and then unpause this when you're ready to check your answer. So to factor this, the first thing you should have done is pull out the GCF, and you should have been left with x squared minus 6x plus 8 Then you were looking for factors of 1 times 8, which is 8, that add up to negative 6. We actually saw one of these the other day. To have factors of a positive 8 that add to a negative 6, we know we're looking at negative 4 and negative 2. So we bring down our GCF. Since this is the shortcut factoring, we can start our parentheses, x minus 4 and x minus 2. Once we've factored it, we do set each of them equal to 0. So we have x equals 0, x minus 4 equals 0, and x minus 2 equals 0. The first one's already solved for. This one only appears one time, so again we state it has a multiplicity of 1. The next one's going to have an answer because we're going to add 4, so x equals 4. Also only appears once, multiplicity of 1. Add 2 for the third 0, x equals 2, multiplicity of 1 because it only appeared once. So what this means at these 3 points, we have straight lines that go through them, and then we curve to make all the rest of it. So we put a point at 0, a point at 4, and a point at 2. Now, going back to how we know our ends, so again our highest degree is 3. That's odd, so we know the right and the left are going to do different things. Well, it's positive, so that means the right side goes up. Since it's opposite for the odd degree, the left side goes down. So I know the dot all the way to the left, the line has to go down from it. And the point all the way to the right, the line has to go up from it. So now we fill in the gaps, knowing that each of these goes straight through. So at this point, I can make this one all the way here and then curve it back. Or I could make it go just a little bit before I curve back. Okay, either way would work. Same thing, this one goes straight through, there's no bounces. So it depends on how far straight through I want to make it go before I curve it back up. So this is the overall shape of the sketch of your graph.